Hello, my name is Konstantin Strömel, and I'm going to present our work Narrating Fitness, Leveraging Large Language Models for Reflective Fitness Tracker Data Interpretation on behalf of my co-authors. Let's start with the motivation behind our work. As you can see, the conventional personal informatics systems in this field of fitness tracking are goal and performance oriented. This means there's a clear quantitative focus where your life and your fitness activity is reduced down to the mere numbers you produce, like your step count or the numbers of calories you burned. Thus, it remains a challenge for HCI to study how we can design PI systems that focus less on the numbers, but rather encourage reflection without just quantifying your performance. So in our work, we want to promote reflection on your activity and ultimately well-being. This leads us to our research question. How can we use large language models to encourage engagement with and facilitate reflection on fitness tracker data? Here you can see an overview of the research activities we conducted. We started with a series of interviews that informed the prompt design, so the way our language model can actually produce these narratives. Then we built a web page for our online study. All right, let's start with the pre-study interviews. So we had this task of generating narratives through this AI system, but first we had to understand, how does a human actually approach this task? How do people talk about their own fitness activities and create these narratives themselves? So we conducted a series of interviews to find that out. We did interviews with 10 participants with very different patterns of fitness tracker usage, ranging from not using them at all and very skeptical to people that actually used multiple devices simultaneously. So we started with questions about how often or for which activities they use them, how they review and perceive their own data. Then we asked them to tell their own fitness tracking story based on their personal data from the last week. Then lastly, we showed them 3 example narratives that we generated using the language model GPT-4, and then gauged their reactions and feedback. So now to our findings. The LLM output was too general and it was lacking specificity. That is what we summarize under abstraction. Then the tone itself was very patronizing and seemed superficial or lacking emotion. So this is nicely summarized here in the quote: "I would prefer if it sounds like a friend says this to me and not a machine." And the third finding concerning the role of AI, it was seemingly unfamiliar, or there was this lack of personality. And this resulted in challenges with trust and transparency. So, for example, here in this quote, the participant number 5 was talking about this feeling of being judged by a computer. And when it says a significant amount of active minutes, who says this is significant? So he's missing this personality that he can relate this statement to. This leads us to the prompt design. So we used our findings to guide the narratives that we want to create through the language model. So the first one is the scope of the feedback. So we want the narratives to be rather on the general level, as we are lacking some context for the tracking data. And this is a clear limitation. Second, positive framing. So the tones should be neutral and constructive. And third is clarity and directness. So we don't want any ambiguous or vague language. It should be really direct feedback. And additionally, we want to avoid this feeling of patronizing or lack of agency. And here at the bottom, you can see a part of the prompt we use in the end. So it says, your personal assistant that receives fitness data from an individual. Your task is to tell a story based on it. This should be a personalized, high-level overview of the data. And we're focusing on the metric steps. So next up, the online study. For that, we built a web page, and this was the general procedure. So first, the participants were recruited through the web service Prolific. Then we obtained their personal fitness data using Terra API. Then they had to fill out a first survey with some demographic questions and the first questionnaire. And after that, we had 3 different conditions for the data representation that we tested. So they either saw a text representation, a chart, or a combination of both. And then after that, they took the final survey and some open questions. So now this is an illustration of the web page we used for online study. So first here you can select your fitness provider and then log in with your personal account. And this is a first questionnaire. So as I said, we had 3 different conditions: text, chart, or text and chart. So this is an example for the text condition. This is the chart condition with bar graphs representing the steps per day. And text and chart is just a combination, or they're both stacked on top of each other. And here's one example narrative that was created. So you can see it says your fitness data shows a pattern of consistent activity throughout the week, and then describes some days. And then in contrast to that, over the weekend, there was a significant increase in steps, with Sunday being the most active day. In our auxiliary material, you can find a list with hundreds of these generated texts, so you can just browse through and read them. Now to the quantitative results. So the structure of our online survey, we had 273 participants with a mean age of 43 years. And the question that was guiding our research here was, what are the differences between presenting PI data as standard chart and LLM-generated text in terms of supporting reflection and user experience? So for that, we used 3 different standardized questionnaires. The first one is the Reflection Rumination Questionnaire, RRQ, the Technology-Supported Reflection Inventory, TSRI, and the User Engagement Scale, UES in the short form. We conducted one-way ANOVA-type procedures for all the measures in the study, and even though we found no significant effect on the total score, we found a significant effect for the TSRI subscore C, which means comparison. So the text scored significantly higher than the chart in terms of comparison. And in the user engagement scale, here we also found significant effects for 2 subscales. On the left side here, you can see the focused attention subscale, and on the right side, the reward subscale. And again, here text received significantly higher focused attention and reward scores than the chart condition. Now the qualitative results. We asked the participants how they interpreted the different forms of feedback presented in the study, and they were asked to just provide 1 sentence in an open question format. And we grouped our findings with the first group being interpreting feedback. So when the participants saw this text representation, they discovered some new activity patterns or external factors that influenced their activities. And it was also helpful to identify trends and some unusual occurrences. For example, this participant noted that he recently fractured a bone, so he was limited in the amount of activities or steps in this case that he could do. They also related the presented feedback to their own personal goals, such as their step count target. So in this tracking goals, this person says, I love how it knew exactly how something could have caused me not to hit my targets. That's mind-blowing. I want to use this every day. So this is a very positive feedback. And then lastly, comparison. Here we describe how participants reported comparing their activity levels featured in the representation to different reference points. And they all found that the text representation was very valuable for this. So it was very easy for them to understand some new patterns or compare the activities different days. And this participant commented on, I can see that working from home and a busy weekday impacts my activity level. It was clear that I'm more active on the weekend. Now to the discussion. So please refer to our paper for a very detailed discussion on the implications of the possible use of AI-generated narratives in personal informatics. Due to time constraints, I will just talk about some limitations and future outlook. So the first limitation that is obvious is that it was an online-only study, so we could only use the questionnaires that we used, but maybe if we would use behavioral measures such as eye tracking, you would get new or different insights into how they perceive the text and the charts. Also, we only used steps as a single fitness metric, but in the future you could use different metrics to generate the narratives. And then when you use a large language model, there's always this inherent bias and the limitations of the large language model itself. So we cannot have full control over the outputs and ensure exact replication in future studies. In the future, we could enhance the interactivity of the system, improve the quality of the narratives through fine-tuning a model and personalization. And there are also two industry examples that used a similar approach. One is the Whoop Coach by OpenAI and Whoop, or Google and Gemini. They partnered up with Fitbit with the personal health large language model. So to conclude, the LLM-generated narratives provide an effective and rewarding user experience, which augments reflection on personal fitness data. If you have any questions, feel free to contact me.